Hi everyone, in this video we'll be discussing the chemistry section of 31st January shift 1 paper. The chemistry section was slightly difficult as compared to the other papers of January 2024 session. So let's see the questions. Starting with inorganic chemistry. The first question says noble gases have very high boiling point. That is incorrect. Noble gas molecules have strong dispersion forces. That is also incorrect. We know noble gases or inert gases basically have weak van der Waals forces of attraction, and if it has weak van der Waals forces, it will have low boiling point, low BP as well as low melting point. Right? So fourth is our correct answer. Among the following white precipitate is, so if we talk about PbI2, we know PbI2 is yellow. Ammonium sulfide is not a precipitate, it is soluble in water. If we talk about ammonium, this looks like ammonium phosphomolybdate. Instead of phosphorus there is arsenic. So it is also yellow in color. And if we talk about PbSO4, that is white. The correct answer is again 4. Two combining atomic orbitals must have same energy, must have same symmetry, must overlap to less extent, useless, must have unsymmetry about the molecular axis. So yeah, the molecules have to have same energy, the energy has to be the same, that is why then only they can combine, right? They should have same symmetry, yes. For example, if we talk about 2s orbitals, both of them have to have similar sign convention, then only we can overlap them. Right, so same energy and same symmetry. It should be A and B, 2. Next, CFT can explain the strength of anionic ligands. Yes, there is spectrochemical series which can definitely do this. Next, VBT does not explain the color exhibited by coordination compounds. That is correct. VBT is the useless theory. Most useless theory because it cannot predict anything. Whatever has been predicted, we may explain it through VBT, but it cannot predict anything. Next question is from DNF block. K2MnO4 changes into KMnO4 in neutral or acidic solution. Yes, that is correct. It undergoes disproportionation. Actually, both are correct and the reason is also the correct explanation. If we talk about K2MnO4, the oxidation state is +6, and in alkaline medium, and in acidic medium, it will disproportionate. In alkaline medium, it remains as it is. That is why whenever we form this is usually formed in alkaline medium. If we have acidic medium, it will get converted to KMnO4, which is +7 oxidation state. So this is oxidized product, and a reduced product would be MnO2. Then we can have water H plus, all of those things. So basically this reaction is disproportionation reaction. Both the statements are correct and the reason is also the correct explanation of assertion. The structure of CrO4 2- is square planar. Useless. No. If we talk about CrO4 2-, it is tetrahedral structure. You know the structure looks like this. Right, it is tetrahedral, and we say the hybridization is D3s. Right, special hybridization in this case. This is incorrect. Chromate ion changes, not charges, changes to dichromate ion. Yes, that is also correct. CrO4 2-, it is having oxidation state of +6. In acidic medium, it gets converted to Cr2O7 2-. Again +6 oxidation state, the color is yellow here and the color is orange here. So in acidic medium we have something like a dichromate, in basic medium we have chromate. So this is correct. First is correct, second is incorrect. Third is our correct answer. Next, the shape of NiCN4 2- is square planar. Yes, that is correct. Ni is basically +2 and that would basically mean simple nickel was 3D8 4s2. Now we have 3D8 and in the presence of Cn minus, which is SFL, strong field ligand, we will have pairing and the structure would be, the hybridization would be dsp2. We will have a square planar structure. That is correct. This is the typical example which we take in VBT. VBT cannot explain ligand field strength. That is also correct. Cis PTEN twice Cl2 for cis isomerism is not exhibited. If we draw the structure, it's a confusing statement if we talk about PTEN. So let me place En here. It is a didentate ligand, chlorine, 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 chlorine. This statement sounds ambiguous to me. It may be that PPEN2Cl2 will show isomerism or not, and basically there can be a cis or trans isomer, right? So let us not discuss this ambiguous part. NiCl4 2- is square planar? No. Again, the example of VBT, we know NiCl4 2- is tetrahedral because Cl- is WFL, it is weak field ligand, right? So through this 1 and 2 are definitely correct, so I can choose this. So in this session of January, we have been seeing a lot of questions from chemical bonding, directly asking hybridization and shape. And we know SO2 is sp2 hybridized, right? H2O is sp3 hybridized, we know that. NS3 is again sp3 hybridized. I hope you know how to calculate hybridization through the formula. I have told that in the previous sessions. If you want another way, through the structure we can calculate through sigma bonds and the number of lone pairs. BCl3 is not the correct option because it is trigonal planar. SiO2 is actually a sheet-like structure. It basically is in this form, and if I talk about the hybridization of silicon, it is sp3. CO2 is a linear structure. BeCl2 is again a linear structure. The hybridization would be sp. In this case also it is sp. So I think the correct answer is 3. For NiNH3 whole 6 2 plus, spin only magnetic moment is this. So if we talk about Ni plus 2, it is, we just saw it is 3d8 and it is octahedral, and for octahedral we need 6 positions. So basically it could be either sp3d2 or d2sp3, but d2sp3 is not possible. The hybridization would be sp3d2. If I draw the d orbitals, we have T2g here and Eg here, 8 electrons, 1 2 3 4 5 6 7 and 8. So there are 2 unpaired electrons. If the number of unpaired electrons are 2, the value of mu, which is spin magnetic moment, would be root of n into n plus 2, that is root of 2 into 2 plus 2. So I think that is root 8, or I can say 2 root 2, and 2 root 2 is basically 2 into 1.414. So that would be 2.828. Approximately the answer would be 28.28 into 10 to the power minus 1. So nearest integer would be 28. Right? In this session we have also seen lot of questions from spin magnetic moment. So that was all about inorganic chemistry. Let's move to physical chemistry. Select the correct option for isobaric process. Now one may say this is a question from states of matter, but again one may argue that through ideal gas equation or mole concept, thermodynamics, in that topics also I can teach isobaric process. Isobaric process is such process, one such process in which the pressure is constant. And if pressure is constant, we know V by T is constant. right? So if we talk about an ideal gas, through that I can say V by T is basically nR by P. So V by T is, V's are Y, T's are X. So this is Y by X and this is equal to our slope M. So Y is equal to mx. If we talk about the slope, slope is nR by P, right? In which case slope is higher? In the case of P1 the slope is higher. Let me say graph 1 and graph 2. So slope for graph 1 is higher than slope of graph 2. So slope is nR by P1 in the first case and we have nR by P2 in the second case. So I can see it should be P2 is greater than P1, right? Correct option is 3. Next, usually this type of question is not asked from electrochemistry, but this time they have asked which of the following metal is used in battery industry. So whenever we talk about primary or secondary battery, usually we talk about lead storage battery or zinc Hg, right? The cell may have zinc and Hg. These are the usual cases, but in NCERT they have also mentioned in a small paragraph about nickel cadmium cell. We never have manganese, iron or chromium. So it is nickel cadmium cell which is used in battery industry, right? Direct question from NCERT. Among the following solution showing positive deviation. So positive deviation means delta V is greater than 0, and delta V is greater than 0 means after mixing interactions are getting poor, right? If I talk about acetone and CHCl3 which is chloroform, acetone alone is not having lot of interactions, CHCl3 alone is not having lot of interactions, but on mixing, this is a typical example. What happens in case of CHCl3? This hydrogen is involved in hydrogen bonding from acetone part, right? So interactions are getting better. That means negative deviation. This is negative deviation. In acetone and CH2, initially they were at least with the similar molecules. One acetone molecule was with another acetone molecules, and they may have had some van der Waals forces of attraction, but when mixed the interactions get poor. So this is actually your answer. Now why not 3 and 4? Because HNO3 in water, HNO3 in water will basically undergo hydrogen bonding, a better extent of hydrogen bonding. HCOH will undergo hydrogen bonding, again a better extent. So the interactions are getting better. So all these 3 examples are of negative deviation, right? Correct answer is 2. Now I do not want to tell this, but I hope you know the equilibrium constant is basically the concentration of the product divided by the concentration of the reactant, and we only write those species which are either aqueous or gaseous. In this case all are aqueous, so we'll write this product by reactant, and I think it is first one, no? Yeah, it is the first one. They cannot ask a question like this. Next question is little bit better. So if we talk about a first order gaseous reaction, it is given to us. So A is giving B plus C. At T equal to 0, the initial pressure was P0 because only A was present. After some time, what will happen? It will dissociate. We will get P0 minus X. This is X. This is X. Right? And at this point of time, the pressure is PT. So I can say PT is P0 plus X plus X. Sorry, P0 minus X plus X plus X. So it is basically P0 plus X. And if we talk about the rate constant, it is basically 2.303 by T log A0 by AT, or initial pressure. You may get confused, so I am writing initial pressure of A divided by the final pressure of A, right? This is final pressure of A. If we talk about the final pressure of A, it is P0 minus X. So actually the answer which I am looking for is P naught by P naught minus X. Now through this equation, what can I say? I know X is basically Pt minus P naught. I am sorry, here I have removed log only. Now let me add log back. So log of P naught minus X. So 2.303 by T log of P naught, which is P naught divided by P naught minus Pt minus P naught. Acha, here instead of P naught they are saying Pi, one and the same thing. So 2.303 by T log of P naught by 2 P naught minus Pt, or I can say Pi by 2 Pi minus Pt. 1 is our correct answer, right? Next, I think this similar question they have asked in 27 January shift 1 paper. So basically we are talking about a combustion reaction. In this combustion reaction we are getting 22 grams of this. That means half a mole, right? 22 by 44, half moles of CO2. And if I balance this, this is balance reaction. So from 1 mole of CH4 we are getting 1 mole of CO2. That means I have, from half mole I'll require half mole. Acha, one step lesser they have asked in this question. So half mole basically means 0.5 mole, and they are asking to write the answer in this fashion. It would be 5 into 10 to the power minus 1, or I can say 50 into 10 to the power minus 2. So X is basically 50. Right, again an easy question. If 1 Faraday of electricity is used in discharging of Cu plus 2, then find the mass of Cu plus 2, Cu which is deposited. So we know Cu plus 2 will react with 2 electrons and it will form Cu. So I can say if we have 1 mole of this, it will react with 2 moles of this, but 2 moles of electron will have 2 farad of charge, but they are saying we have only 1 farad. So from 2 farad we need 1 mole. So from 1 farad I will need 1 by 2 mole, right? And the mass would be, actually this is also the same. They were asking the mass of Cu, so we will be forming half mole of Cu. So mass would be half into the molecular mass, which is 63.5. So I think our answer is 31.75, I guess. Yes, close to 32. Right, next question is calculate the Gibbs free energy in kilojoules for the reaction given below. Kp is given to us and the log value is also given to us. So we know delta G naught, direct question, no, minus RT ln K, or if you want to talk in terms of log, it is minus 2.303 RT log K, Kp, and Kp is given as 70.94. The answer is to be calculated in kilojoules, so I'll divide by, first of all I'll put R in joules, which is 8.314, temperature is 300, into this value is 1.8509, divided by 1000, because answer is required in kilojoules. So 8 3 is 24, 24 into 2 approximately 48, 48 into 2 is approximately 96, by 10 approximately 10. I think this will be our answer. Next, let's move to organic chemistry. Organic chemistry has been very easy in all the papers this time. So we know red phosphorus and HI is basically something which will convert everything, be it OH, be it CHO, to the respective hydrogen part, or I can say CHO to alkane part. So we know through the first reaction we get N-hexane. HNO3 is a strong oxidizing agent, so we get saccharic acid. Right, glucose has CHO at the top, CHO at the top, CH2H at the bottom, and OH with HNO3 we get saccharic acid, or glucaric acid, which is COH at the top, COH at the bottom. And with bromine water, we know with bromine water we will get COH here and CH2OH here, OH, H, OH, OH. So that is gluconic acid with NaHCO3 doesn't react. So you can match this. Next, alcoholic KOH, we know it shows E2 elimination. So in the first step, we are going to get an alkene, then HBr, it's Markovnikov addition. It will form carbocation, it will be more stable. Here we'll get this product, aqueous KOH basically shows SN2. So we'll get CH3, CH, CH3 and OH at this point. So this is propane 2-ol. Very easy. Adsorption method is used in distillation. They cannot use sublimation, extraction. They do not use. It is used in chromatography. You know this thin layer. If we talk about thin layered chromatography, which is TLC, we take a plate on which we take a solute and we take a drop of the solute and we add it here. So some part of this, it may be a mixture of solutes. So what may happen is some of the solute may get adsorbed, right? So it is basically based on the adsorption phenomena. Chromatography is based on adsorption phenomena. Again a question from IUPSC, again a simple question. We know C double bond O ketone is a principal functional group in this case. So we will say 7OH will be like a substituent, right? So we will not call it OL at the end. We will actually call it hydroxy. It is 7-hydroxy heptane 2-1. 7 carbons, heptane 2-1. Correct. pK of phenol is 10. If we talk about phenol, this is phenol, this is ethanol. Yeah, phenol is more acidic because we will get O minus in this case, right? This is resonance stabilized. So yeah, we know phenol is more acidic, hence I can say Ka of phenol is more than ethyl alcohol, right? But if we talk about pK, it will be the reverse because we know pK is basically minus log K. So this will be the order. Ethyl alcohol should be more, and through this data, I believe this data. Whenever this type of question comes, we believe in that data, right? You may wonder ki sir, it may be 10 or 15 or 10 or 12. It may be the case, but we usually believe on that. Ethyl alcohol is more acidic than phenol. Useless. First one is correct, second one is incorrect. The answer is the third option. The sextate, that means 6 electrons. 6 electrons will be present in carbocation. I hope you know that. Let us take a simple example of CH3 plus. So you can see there are 6 electrons in CH3 plus, right? The total number of different alkanes formed when the following mixture is subjected to electrolysis. So basically they are talking about coal-based electrolysis. If we talk about coal-based electrolysis, you know we have something like CH3CO minus, it loses its electron, we get CH3CO dot, it loses CO2, we get CH3 dot. So basically in this reaction we are getting CH3 dot and C2H5 dot. Now either they can connect with themselves, which is a self product, or they can form a cross product. So basically I can get, you can see in this case this is ethane, propane and butane. So basically I have 3 products in this case. Very simple again.